Hi there, folks. Welcome to another section of non-cloud chapters. And in this chapter, I'm going to talk about SQL. And SQL is very, very important, irrespective of whether you want to become a data engineer or a data scientist or data analyst, etc. SQL is needed, and this is an optional section. So if you already know and you are already familiar with SQL, you can completely skip this chapter. And if you do not know SQL, then I would recommend that you go through this chapter. Even if you know basic SQL, this chapter will give you a fair amount of idea of a little bit of advanced SQL features and queries also. And this is going to be the agenda. I'll start with SQL introduction. Then I'll talk about various database objects. You'll get to know what a database is in the discussion. In the database objects, I'll talk about database and then schema and then tables. Then I'll talk about CRUD operations. CRUD means create, read, update, and delete. And essentially in SQL, we call CRUD as insert, select, update, and delete. The term CRUD was introduced in the NoSQL world, but now it is used in a generic way. But anyway, we'll talk about insert, select, update, and delete, which refer to the CRUD operations in SQL databases. Then in the fourth topic, I'll talk about complex SQLs, wherein we'll discuss about joins, unions, excepts, etc. I'll talk about views also and a few other things. And then I'll close with analytics SQLs, wherein I'll talk about window functions, common table expressions, materialized views, etc. So the last section wherein I'm talking about analytics SQL, that is an advanced portion. And if you want, you can skip the last section also. So let me introduce SQL. So first of all, what is SQL? It is also known as SQL. So I can use the term either SQL or SQL. And SQL is used a lot actually. So the full form of SQL is Structured Query Language. It is known as SQL or SQL. Now the first question is that why it is called structured. Why do we have the word structure itself? The reason is that it tells about the data that this particular programming language or query deals with. Whenever we are using SQL, it tells you that what kind of data you are going to deal with. You know that because we are using SQL, this is how the data would be, and that data has to have some structure associated with it. Now the question is, what is a structure? So structure is predefined in the form of tables using something called columns. Let me give you an example. So let's say this is a table, and if you have dealt with SQL, you know that it is similar to an SQL table. And here we have multiple columns. So if I have to count, I have around 3, 3, 6, 4, 10 columns, and I have few rows. So when we are talking about structure, we are saying what these columns are. So we'll be defining that, okay, these are the names of the columns. For example, order ID, customer ID, order date, delivered date, etc. These are the column names. And this is the structure of this entire table. And whatever row we put in this table should have the exact same columns everywhere. Meaning, even if you have 1 million rows, all those rows should have data corresponding to only these columns, starting from order ID and ending in discount. I cannot have value with any other column. That is not possible. So it's a very rigid structure. Before dealing with the data, we define the structure of the data, and throughout the life cycle of this object, which is known as table, the structure would be the same. Of course, we can add columns, remove columns, etc. But again, even if we add and remove, after the modification, the structure would remain the same. And then data reside in the table as rows. Now the data is basically the rows. So each row would have order ID, would have customer ID, order date, deliver date, status, price, location, quantity, sold by, discount. These columns or values for these columns should be present in all the rows. It might so happen that some rows for some columns do not have any values. For example, let's say status is not there or location is not there. That can be possible, but it does not mean that column is absent. It means the column is there, but the value of the column is not there for that particular row. So this is what a structure is. So define a structure of a table or an object for that matter, and data resides in this object in the form of rows. Then you have query. So what is this query? Query is basically the format or the way we deal with the data. For example, if you have to do something on the data, we use query, and this is how we operate on data. We can read data, we can update it, insert data, or delete data. Now all these things are done using query. So that's what structured query means. And then you have language. Language is nothing but it is a programming language just like Python, Java, or C. So that's why it is called a structured query language or SQL. The most underlining or the crux of this particular slide is that SQL deals with data which has predefined rigid structure. So the data should follow a certain structure. So it cannot deal with data which does not have any structure. So that is the underlining of this particular slide. Now, after defining SQL or after telling about what SQL is, let me take you through the history of SQL at a very high level. It is a programming language to retrieve and manipulate data in databases and database objects like tables. And it was developed at IBM back in 1970. So it's been approximately 50 years, more than 50 years rather, that SQL is there in the IT world or in the technology world. Now, it is not going to go anywhere. In fact, SQL is getting stronger, and now SQL is very, very famous, and almost all the developers or all the people who are working in the technology world would know what SQL is, or at least must have heard about SQL because this is one of the most famous programming languages that deal with data. The original name of SQL was Structured English Query Language. That's why SQL is there. Then it was changed to SQL. The English word was removed from it. And again, as I said, that's why the name is SQL. So the short form SQL continues to this day. Now, this is the most important thing of this particular slide, that it is used as standard for RDBMS technologies. When I say RDBMS, it means Relational Database Management Systems. I'll talk about Relational Database Management System later on, but we also call them as relational databases. So it is the Suomoto language for dealing with data that are relational. And just to introduce, because I told you the term RDBMS, which is Relational Database Management System, what is database? Database is a place where data or information is stored and it is persisted in disk. This is not temporary. So database would have persistent or permanent data about some organization. For example, if you go to a bank, then it would have information about, or it would have data about the bank. Let's say customer information, account information, loan account information, etc. If you go to a retail organization, it will have information about orders, it will have information about product inventories, customers, etc. So data is stored permanently in database. And RDBMS is a database technology that is used to store relational data. So relational data means that in a database there can be multiple objects and those objects are related to each other. That's what RDBMS is. I'll tell you how that relation is built, but essentially that's what RDBMS is. And some examples of relational databases are like DB2, which is basically a product from IBM itself. Then from Microsoft, we have SQL Server. Then you have Oracle, which is basically the most famous relational database till date. Now, these three are actually commercial databases, and you have to pay hefty license cost to acquire these databases. Apart from this, we have open source databases also like PostgreSQL, MySQL, MariaDB, etc. Now, these are all open source. There are no licensing cost. for these databases. And the reason I have highlighted PostgreSQL because I'll be doing the hands-on using Postgres database. And don't worry about the other database because the SQL dialect would be more or less similar in all the databases. Now, the top row that you see DB2, SQL Server, Oracle, etc., these are actually operational databases or OLTP databases. So if you do not know what operational database is, please go through the introduction of this course. And on the bottom part, except for Aurora, Aurora actually provides open source databases in a managed offering. All the other technologies that I have mentioned, like Redshift, Snowflake, BigQuery, Teradata, etc., these are data warehousing systems, which are basically used to store historical data to do certain amount of historical analytics, predictive analytics, etc., for some business needs of the organization. So this is the history of SQL, and as you can see, for the last 50 plus years, SQL has evolved a lot, but the basic dialect remains the same. Now, you might ask a question that, okay, NoSQL databases have come. Do we even need to bother about SQL language anymore? Or do we need to bother about relational databases anymore? The answer is, of course, yes. Relational databases are not going anywhere, neither is SQL. Now, but before telling about that, let me tell you very interesting stuff. So, you know what NoSQL databases are. NoSQL databases are technologies that do not use SQL. Now, at a very high level, why NoSQL databases came? Because what happened is that in the early 2000s or late 2000s, 2000, first decade of 2000s rather, the application pattern started to change because of the inception and popularity of internet. So relational databases posed some challenges, meaning that earlier when relational databases were there back in 1970s, the number of concurrent users, the number of concurrent applications used to be very less, maybe in the tens. And after the usage of or popularity of internet, that pattern has changed drastically, meaning that you can have millions of concurrent users, you can have thousands of applications running concurrently and accessing the same database. Now, in case of relational databases, it cannot scale. It is not meant to scale for such a large user base or such a large concurrent connections. So that's why NoSQL databases came into picture. Of course, that is also changing because we have technologies like new SQL database, which merges the advantages of SQL and NoSQL databases. And there are a lot of new SQL databases also. But NoSQL databases shine for their scalability reasons. It is very difficult to scale relational databases because of technology limitations. But NoSQL databases actually overcome those technology limitations by forfeiting or compromising on certain features that relational databases or SQL databases provide. And those features are very important, by the way. That's why SQL databases are still relevant, and it will be relevant for large amount of time in future also. Now we have NoSQL databases like DynamoDB, which is AWS's most popular NoSQL database. Not only for AWS, it is also one of the top 5 most popular NoSQL databases. But DynamoDB has an interface called Particle. And what Particle is, it gives a SQL interface to run ad hoc queries on top of DynamoDB. Then we have something called Yugabyte, which forms in the category of new SQL databases that I was talking about, which mixes the advantages of both SQL and NoSQL databases. But Yugabyte actually gives an interface which is similar to PostgreSQL. That is also a relational database. Then we have TIDB, which is basically a HTAB database, hybrid transactional analytical processing, and that also gives an interface on MySQL. MySQL is another relational database. Then you have CockroachDB. CockroachDB is also a distributed SQL database. The underlying architecture and the underlying technology is very different than relational databases, but the endpoint that it gives to the developers are using something called SQL or distributed SQL, which is similar to SQL. Then we have big data technologies. You might have heard about Hadoop. Now Hadoop is very famous, and it became very famous back in 2010s, 2009s or 2010s, and it brought in the revolution on big data. And Hadoop has two components. One is MapReduce, which is used for processing, and then there's something called HDFS, which is a distributed storage. So MapReduce is distributed processing and HDFS is distributed storage. What is distributed processing? Basically, it means that the processing, or if you are running a program which is used to process your data, that program would run on different computers or different servers. And once the processing of all the programs would done, then another component would gather the result from those different output of different programs and then put the result back to the end user. Similarly, you have HDFS, which is Hadoop Distributed File System. It is also a distributed storage, and it is similar to distributed processing, but instead of program, the data would be distributed across multiple servers or nodes. And of course, there's way more complex that it sounds, and there are too many components which are there in HDFS. But again, Hadoop actually bring in the revolution on distributed processing. So typically what Hadoop contain, it would contain a Hadoop cluster, and the processing would be, or the MapReduce layer would be written in Java. It's a code that is written in Java, and it would be submitted to the Hadoop cluster, and then the processing would be done, and after the processing is done, the results would be returned back to the code, and that's all it is. But the problem is that it is written in Java, and there are a lot of developers who do not know Java. So basically, if you go and take a look at the data world even today, very few people would know Java. Python is something that maybe a lot of people would know, but Java is something that in the world of data engineering, in the world of data scientists, etc., they do not know the Java technology as such. So that's why the adoption of big data was not as much, because of this particular limitation. The data world developers were not able to use it as one would expect. So that's where Hive came in, and it was brought in by LinkedIn or Facebook, I'm not sure. But anyway, so what Hive did, it created a layer on top of MapReduce using something called Hive Query Language or SQL. Now what it would do, it would place a layer on top of MapReduce and it would submit query using HQL or Hive Query Language, which is very similar to SQL. And one would submit that SQL statement to Hive, and Hive processing engine would convert that SQL to Java code and then submit it to the Hadoop cluster. And the Java code would run as usual, then return the result. Now, the reason for me to saying this is because you can understand the significance of SQL. Even though big data was meant to solve a processing problem of huge amount of data, which cannot be done by relational databases, because people were not comfortable with Java, they had to come up with Hive, a layer that converts SQL language to Java. And after the invention of Hive, big data became really popular, and the adoption also increased exponentially. That's how SQL is important in the world of NoSQL databases, in the world of big data technologies, of course, in relational databases and data engineering as a whole. Now, I've talked about multiple technologies, right? Now, the question is, who use SQL? Is it only for data engineers? Of course, data engineers use SQL a lot, but there are a lot of other personas who use SQL. For example, data scientists. And data scientists use very complex SQLs also. So if you aspire to become a data scientist, you have to know SQL. Same is the case with data analyst also. If you have to analyze certain amount of data using some technology or the other, you have to know SQL. So without SQL, it's very difficult to do data analytics. If you are using, let's say, Excel sheet to do the analysis or data analysis, that is fine because the size of the data is pretty small. Try to open a file of, let's say, 100 MB using SQL. It's very, very difficult. It will take fair amount of time. Now I'm talking about 100 MB here. Imagine you have data with 100 GB or maybe tens of terabytes. So how do you perform analytics on top of it? How do you analyze that data? So that's where SQL has to be used, and in some shape or form. And you don't worry about the underlying technology because maybe Hive is running, or there's another technology called Spark which also does distributed processing on big data. You'd be running SQL, but those engines would convert that SQL to its native language to do processing on data and eventually give you the result. So that's why it is important for data analysts also. Business analysts also need SQL because business BAs or business analysts have to they do derive business functionalities, they take business decisions, etc. And business decisions are taken by data, right? So most of the business decisions are data driven, and you have to analyze data, and SQL becomes imperative in this case also. Application developers, so does not matter whether you are Python developer, Java developer, or Node.js developer, some time or the other will have to work on SQL. Of course, database administrators, machine learning engineers also have to know SQL. Then there are BI developers who use BI tools like Power BI, Tableau, Click, etc. They also have to know SQL to implement those BI functionalities. And finally, the marketing analysts have to use SQL also for the same reason that other personas are using. So what I'm trying to say here is that SQL is very, very important. And if you are working on the technology world, if you are using some sort of IT technology, it's only time that you use SQL. So if not sooner, then later you'd be using SQL for sure. Okay, so I have talked about SQL, I have talked about the usage of SQL. I have also shown you that there are various databases which use SQL. Both operational databases like Oracle, MySQL, Postgres, DB2, etc., and data warehousing systems like Redshift, Teradata, etc. Now the question is, all these are different technologies, right? And it might be the case that they use radically different SQL. The question comes, do you have to learn those radically different SQLs? The answer is no, because SQL is completely standardized. All the database technologies that you have seen or that I have mentioned, they use some shape or form of the standardized SQL, and which is called ANSI SQL. The full form of ANSI is American National Standards Institute, and it's a organization of 270,000 organizations, maybe more than that, and they combinedly decide the standards of maybe programming languages, database technologies, and eventually SQL. So as I said, they might decide on different programming language standards, etc. And that's where ANSI SQL comes. It provides certain rules, it provides certain syntaxes, maintains certain standards and specification of how SQL should be. If they define these things, like this, there's an organization who decides that okay, these are the rules that should be there, these are the syntaxes that should be there, standards and specifications that should be there in SQL. So which means that all the database technologies that you see, at least the relational database technologies, they have to conform to ANSI SQL because this is the standard. Now if there comes a relational database which says no, they are not ANSI SQL, there's high chance that that relational database technology will not be adopted at all. That's why the relational database technologies have to be ANSI SQL compliant, and that is the reason that all database technologies implement subset of ANSI SQL, meaning all the database SQLs are a superset of ANSI SQL. Now that's why if you learn SQL in any one of the database technologies, you can take that and use the same SQLs in another database technology also with a very minimal changes. So you might have to learn a little bit more thing, not too much. All relational databases implement full or subset of ANSI SQL, or databases become ANSI SQL compliant. So whenever you hear that there's a technology which supports ANSI SQL or that is ANSI SQL compliant, and if you know SQL, you'd be able to work on that technology, irrespective of that is relational database technology or NoSQL database technology or big data technology, does not matter. If that is ANSI SQL compliant or ANSI SQL compatible, you'll be able to work on it if you know SQL. Okay, so enough about history and what SQL is. Now, I have been talking about databases, right? So these are the various databases like Oracle, MySQL, Postgres. And you know what a database is. A database is used to store information. Now the question is, how does database store information? So that's why database server plays a very important role. So database, when I talk about database, I'm meaning relational or RDBMS databases. It is a server where data is stored, and you know what a server is. A server contains CPU, RAM, and its own storage. Storage would be associated with the server as well. So it will have a compute part and it will have a storage part. In the compute part, it would use CPU and RAM along with a lot of other things. I don't want to go into the details of that. But along with that compute, it will have a storage portion also, wherein the actual data would be persisted or stored permanently. So that's what a database server is. And typically, database servers run in isolation, meaning that we do not install any other software or any other platform or any other program where database is installed, because database is one of the most critical components of an application, and it plays a very important role in the data engineering pipeline also, because this is where data is born, this is where data is captured and then sent to processing by the data engineering pipeline. And it is important for application developers also, now in the application pipeline also, because this is where the application pipeline ends. So if you are using any application in your smartphone, in your laptop, in your desktop, etc., all those applications would be storing some data or the other in a database. So it's very rare that there would exist an application which is not using database. So that's why database is one of the most critical component of any application. And also that is the reason that it runs in isolation, so that no other software can impact the database program or the database software that is running. And you might have guessed that database technologies or database server are queried using SQL. Okay, now we use SQL and send SQL statements to the database server, and the database server executes that SQL statement and sends the result back to the place where the query was sent from. Now SQL is a programming language, right? Because it is structured query language. So it also needs a server to run, because this is also a program. Now we need a server for SQL also, and this is called a client machine or a client server. Typically it is not called a client server. Server is something where you send the request and it is serving something, and client is something where the requests are emanating from. So in the case of SQL also, you'll run the SQL statements in the client machine and then you'll send it to the database server. Database server will execute it and send it back to the client machine. So this might be called as the client and this might be called as the server, albeit database server. So as you can see, this is a client server architecture as well. And SQL is also run from a client machine by connecting to the database server, and the connection happens over network. The client and the server machine would communicate over network. So whenever we run SQL statement, that would travel over the network and reach the database server, and database server will execute that particular SQL statement and then return the result set back to the client machine. And the client that we are going to use is called PSQL, which is basically SQL for PostgreSQL. The installation would be pretty easy, and we'll be using an EC2 instance for the client machine, and we'll be using Aurora serverless PostgreSQL for database server. So this would be the EC2 instance, and this would be the Aurora PostgreSQL database server.